Alright, so sequence is 1.2. Okay, so complete each table by looking for the pattern. So we've got 2, 4, 8, 16, 32. Okay, we should be able to say, we could say we're adding 2, then 4, then 8, then 16, then 32, right? Adding the same thing we just had to get 64, then 64 to get 128, then 128, and we get 256. Okay. Another thing we could also say is we're just timesing each one of these by 2. Okay, using a multiplication pattern. Alright, 66 to 50, we'd probably be subtracting 16, which if we subtract 16 gives us 34. Minus 16 is 18, so minus 16 would give us 2, minus 16, negative 14, minus 16, negative 30, minus 16, negative 46. Okay, 160 to 80 to 40. So now it looks like we're cutting it down by half, right? Subtracting 80, then 40, then 20. Kind of similar to this pattern, so is there a better way? Maybe divide by 2? Yeah, so this would be 10 dividing by 2, 5. Dividing by 2, 2.5 or 5 halves. Dividing that by 2, 1.25. Okay, then negative 9 to negative 2. We'd be adding 7. Add 7. Yep, add 7. So 19 plus 7, 26. Plus 7, 33. Plus 6, 40. Alright. And it says use variables to create equations that connect with visual patterns. Okay. So, step 1 we have 1 box. Step 2, tiles, we have 4 tiles. Step 3 we have 1, 2, 3, 4, 5, 6, 7. So what would it look like? Okay, well what's happening here? Well, it looks like we're basically adding on 1 tile on each, right? So I'd have 1, 2, 3, then that middle one, 1, 2, 3, and from that middle one, 3 more. So step 5, I'd have 1, 2, 3, 4, then the middle one, 1, 2, 3, 4, and then 1, 2, 3, 4. Okay, so step 4 and 5. The students in a class were asked to find the number of tiles in a figure by describing how they saw the pattern of tiles changing at each step. So this was 10, and this was 13. Match each student's way of describing the pattern with the appropriate equation below. Note that S represents the step number and N represents the number of tiles. So we have N equals 2S minus 1 plus S minus 1. N equals 3 times S minus 2. And then N equals S plus 2 times S minus 1. So 6. Dan explained that the middle tower is always the same as the step number. Okay, which makes sense. 1, 2, 3, 4, 5. Okay, so that would be S, right? He also pointed out that 2 arms on each side of the tower contain 1 less block than the step number. So here, there were 2, and then 1 and 1. 3, and then 2 and 2. 4, and then 3 and 3. Okay? So what would be happening here? Well, we take these and double them, right, after we've subtracted 1 block. So that would be like S minus 1 would be subtracting 1 block, and then we double that. Okay? And we add those together. So Dan had formula C. Okay, 7 says Sally counted the number of tiles at each step and made a table. She explained that the number of tiles in each figure was always 3 times the step number minus 2. Okay, so where would this minus 2 come from? Well, if we think about what we were doing in class, it's like she went backwards, and since she was adding 3 each time, that repeated addition to where we get the 3 times S, and if we jump back to our starting number, 1 minus 3 would be negative 2, so B was definitely Sally. Okay? Another way to look at hers is to kind of say, what if each of these towers had the same amount? Okay, so there's that left side. There's the right side. And then there would be the tower up, right? So there's 3 groups of 5. That's where the 3 times s comes. But when we combine them, like when I pull this down and pull them all together, these 3 tiles end up merging, creating one tile, or I go 3 minus 1, okay? Or 3 becomes 1. So we're subtracting 2 of these tiles out, that minus 2. Okay, so that makes 8 would be A. Let's see if we can figure out why. Nancy focused on the number of blocks in the base compared to the number of blocks above the base. She said the number of base blocks were the odd number starting at 1, and the number of tiles above the base followed the pattern 0, 1, 2, 3, 4. She organized her work in a table at right. Okay, so she was saying, let's clear us some space. So 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. Okay, so if we look at this, so she's saying the step number, okay, so 1, 2, 3, and 4, okay, she said the number of base blocks were the odd number starting at 1. So base was 1, then 3, then 5. Okay, so 1, 3, 5, and then 7. Okay, and the number of tiles above the base followed the pattern 0, 1, 2. So 0 above, 1 above, 2 above, 3 above. Okay, so then notice the step number, it's always 1 less, right? So that's where the s minus 1 comes from. And then the base, notice that's the same. So we get 1, 1, 2, 3, 3, 5, 4, 7. So she realized that if you take this number and double it, and then minus 1, that's where you get that. So that's kind of where her information comes from. But anyway, there we go, guys. So some interesting thought processes going on right there.